Okay, so now we're going to talk about logarithms as an inverse. Sorry again I can't be there, but I will be there this afternoon, so if you have any questions for me, I will be here after school. But as a warm-up, I want you to do questions 1 and 2. I want you to write them as inverses. So I'll have the sub pause the video so that you can do questions 1 and 2, and then we will go over them. Okay, so going over questions 1 and 2. So remembering how to write an inverse. We're dealing with x's and y's, and we need to switch our x and our y, right? With inverses, x and y is always switched. So we have x equals 2, y is over there, and then now what do? Well, we need to get y by itself. So first thing, we got to work on the outside. So on the outside's a 2. And it's 2 times because there's no plus sign. If there's a plus sign, then we would do something different. But because it's multiplication, opposite of multiplying is dividing. So you have x over 2 equals the square root of y. And then how do I get rid of a square root? Well, to get rid of a square root, right, opposite of square rooting is squaring. So we need to square the other side. So you can just leave it like this, or you can distribute, right? Exponents, you times, you distribute it to both of them. And then 2 squared is 4. Okay, so that's that first one. Let's go to the next one. So again, we need our x's and our y's, and we need to switch them, right? I switched them. This was a y, and we switched our x and our y. Now we need to undo it, so we start from the outside. So to get rid of an exponent, we need a radical. So we get y minus 3. And then we add 3, but it's to the outside because it's happening after we took the radical. So it's outside, and that's what we get. Okay, so now let's look at question 3. So I know this is a little different if you're in regular. On regular, you already have the graph, and it's asking you if these two graphs are inverses. So I want you to pause this, and if you're in honors, I want you to graph this function and its inverse. So if you need to use a table, you can. And remember, inverses reflect over what line? Oh, that was not a good line. They reflect over that line of reflection that goes through the middle, just as a hint. So for both of you or your classes, work on question 3. So for honors, you have to graph both of them. For number 2, you need to tell if the 2 graphs are on there are inverses. So you can pause it and look. Okay, coming back. So graphing the exponent to the x, if you needed to use a table, your graph should have looked like this. For the function 2 to the x, so this is 2 to the x, and its inverse, remember, to find the inverse, we just see how far away it is from that line of reflection. So we look at the other side, and then we go to the other way. So it has to come in at a right angle, and this one is 1 square away, so the other side, our function needs to be 1 square away. This one's only half a square, so it needs to be half a square. Okay, so the blue one is the inverse function, okay? So if you're in regular, yes, those 2 functions are inverses. Now let's talk about what do we think the equation for this inverse function is. And we kind of already talked about the inverse to exponential functions is a logarithm. And so the base of the exponent would be the base of our logarithm. So this blue equation, or this blue graph here, is what a logarithm looks like. So you notice a logarithm doesn't go past the y-axis, okay? It doesn't go past the y-axis. It just goes down, 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 but it's never going to hit the y-axis. So the blue one is what a logarithm looks like on a graph. Okay, so in the last time we talked about how logarithms and exponents are inverses. So that means to undo a logarithm, we use an exponent. Just like how to undo an exponent, we use a logarithm. So before we get into this, just really fast in this extra space, I know I've done this with you before, but if I have a 2 and I times it by 3, I'm going to get 6. What do I have to do to undo that, to go back? The opposite of multiplying by 3 would be dividing by 3. So these undo each other, they cancel each other out. Same thing here, if I had an x and I squared it to get x squared, what would I have to do to go back? I'd have to square root it. So if I have x squared, to get rid of this squared, I have to square root it and they cancel out. Just like if I had 3x and I wanted to get rid of that 3, I would divide by 3 and they would cancel out, okay? So remember, these opposites cancel each other out. So here, if I'm working with a logarithm, okay, so if I have log base b of x, if I raise this logarithm to an exponent, so I use an exponent, because what's the opposite of a logarithm? An exponent. So that means I'm going to raise this to my exponent. And can you guess what base of my exponent I'd want to use? Well, I'd want to match the base of my logarithm. So here's the base of my exponent, and I'm raising my logarithm to be the exponent. Just like how we have 2 to the x, this log is like the x, it's the exponent, okay? And the reason we do that, because the opposite of a logarithm is an exponent. So they cancel out, and what are we left with? Just x. So when we raise a logarithm with this, raise a logarithm with an exponent of the same base, they cancel out. Just like if I have x squared and I square root it, or how do we do this one? X to the 3, and the opposite of cubing is cube rooting, they cancel out. Same thing with logarithms and exponents, they cancel out. So let's go here. So if I'm starting with an exponent, okay, what do I do to get rid of the exponent? The opposite of an exponent is a logarithm. So we use a logarithm. Okay, so I have b to the x, and I'm just going to take the log of it. And what do you think the base of my log needs to be? Base b. Now, an exponent and a logarithm are inverses, so they are going to cancel out, and what are we left with? X, okay? So we need to think about it that way. They cancel each other out, just like adding and subtracting cancel each other out. So let's practice this, canceling each other out. So apply the inverse rules from above to simplify the following values. The base of the logarithm matches the base of the exponent. So what's going to happen here? They're going to cancel out, and what am I left with? My exponential. Okay, let's look at question 5. I have an exponent, and what's it raised to? Log base 10, right? When there's no base, it's 10. So since the bases are the same, these cancel out, and I'm left with a 4. So I want you to do the rest of them. You can pause it, and then we can double check and see how we did. Okay, coming back. Okay, here, again, when we don't see a base, we know it's base 10. So they have the same base, so they cancel out, and I'm left with a 3. On question 3, remember, ln is the natural log. It has this base e, so they have the same base. We're left with 4 because they cancel out. Here, I'm raising this logarithm to my exponent, but since they have the same base, they cancel out, and I'm left with 26. Going to question 6, again, logarithm, exponent, same base, cancel out, left with a 2. Again, logarithm, exponent. Do they have the same base though? No, but can we make this so that they do have the same base? What's 5 squared equal? It equals 25. So what if we replaced this 25 right here, if we replace this 25 with 5 squared? So I'd have log base 5 of 5 squared raised to the x, and then what do I do with this x? I times them together, right? Whenever we have anything in parentheses, we times the exponents. So I have log base 5 of 5 to the x, right? X times 2 is just 2 times x. Those cancel out, so my answer actually is 2x. Okay, last one, same base, so my answer is 20. Okay. So now we know the new inverse rule for logarithms and exponential values. Use the switching x and y method to write the equation for the inverse function. Okay, so right, we're talking about inverses, so we switch x and y. So I need a y. So we switch x and y, but we need to get y all by itself. So how do I undo an exponent? What's the opposite of an exponent? A logarithm. So I need to take the log of both sides, but what's the base of my log going to be? The same base of the exponent, so log base x. So right, what I do to one side, so I need to take the log of x, I do to the other side. So look, I took the log of both sides. Okay, so now on this side, what can we simplify with this? Well, a logarithm and an exponent are inverses. The bases are the same, so they cancel out, and I'm left with a y. So we have log base 6x equals y. Okay, so this is our inverse function. So f of negative 1 of x equals log base 6 of x. Let's do another one together, and then I'll have you try the last one on your own. So this one, y, we need a y for us to switch x and y. Okay, inverses, we always switch x and y. So we have x equals ln y plus 3. Okay, how do I get rid of a logarithm? You raise it to an exponent. Opposite of a logarithm is an exponent. Well, what base am I going to use? What's the base on this logarithm? It is e, right? It's a natural log. So I'm going to raise both sides. So if I raise this side, so this becomes my new exponent, I need to raise the other side, so x becomes an exponent. These have the same base, and since logarithm and exponents are inverses, they cancel each other out. Okay, so we have e to the x equals y plus 3. Now, is y by itself? No, we still need to minus 3. Okay. Now I have a question for you. There's two options. I want you to tell me which one you think it is. Is it going to be e x minus 3 in the exponent, or e x and then minus 3 down low? Since we're minusing 3 to this whole thing, this is minusing 3 to the whole thing, okay? Not to just the exponent. So this is our inverse function. Okay, so I want you to try 11. So pause it. And then try 11, and then we can go over it. Okay. So coming back, we need to write it as y and x, so we can switch our x and y. So we have x equals 4 raised to the x plus, or y plus 2. Y plus 2. Okay, now this is an exponent. How do you get rid of an exponent? You take the log. What's the base of our log? Well, we're going to have log base 4. That means I need to take the other side. Okay, because we have an exponent and a logarithm, they're going to cancel out. So that's all we're left with on one side. So we bring this down. We have log base 4 of x equals y plus 2. Okay, now we need to minus 2. Now, again, what do you think it's going to be? And I'm putting parentheses so that we show that the minus 2 is coming after. It's not a part of the log, or this one, which it kind of looks like it's part of the log. Okay, so it's this one, right? It's helpful to put these parentheses here so that we know that the minus 2 comes after, right? We already took the log already exists, and then we minus 2. So that's the answer to that one. So if you have any questions, you can ask me next time, or you can come in after school or go to Math Lab to get some help on this.